Alright, so at this point you've got your motors hooked up to Auggie and you've got a status of 3, so everything is running well, and it's time to look at how to tune your motors. In an earlier video I mentioned the point that you want to keep your acceleration as high as you can possibly keep it. This is because in a jerk limited planner you want to maximize the acceleration potential that you can have. Because the jerk limiting planner can lead into a high acceleration, it allows you to turn your acceleration probably 30% higher than what you could in a traditional planner. The downside to that is your homing. When you home, the motion is produced by the pokies and is undoubtedly a bang-bang trajectory path. So if the acceleration is turned up too high, you could lose steps on your home. So when you're setting up your pokies in the pokies configuration, you should probably set the acceleration to the point that the home works reliably, even at that very high acceleration that you're striving for. It's okay if your motor freezes up if you try to go faster. Just make sure that it's reliable at the home speed. Okay, so here we have a program loaded. As I said, you've turned your acceleration up really high on your pokies, and now when you're trying to set things up here, you'll find all you really have is a max jerk limit and a CV radius. Now the CV radius is how large a radius it can make as it goes around past corners. Obviously that helps it to maintain a constant velocity, but it's the jerk limit that you're going to want to be worried about. Now I've got it turned down to 50 here. And you're going to want to start with a low number as well. Even though your acceleration is turned extremely high, having a low jerk means it is not going to accelerate fast. So I've got a feed rate set here of 3,000. Let's just hit run and let it run. Now you can see that as it goes into the corners, it's maintaining a fairly good velocity, but it is slowing down and then speeding up again. And if we look at it on the motor stats, you can see that the S-curves of the motors are taking in changing their speeds are fairly dragged out. If you had a gantry that weighed a ton, you'd probably appreciate that kind of dragged out momentum. But for most of you who are going to be running small mills, you're going to want it to go a lot faster. So what you're going to do in order to see how things run, or in order to tune up your system to be optimal, is to increase the jerk. Do a run on something like a test pattern like I have here. Observe your machine and how smoothly it runs, and then keep increasing max jerk limit. Jerk on most machines would approach infinite when you take off. So here, if you were to limit jerk to even 5,000 or 50,000 or 500,000, you're still smoothing it from the path of a bang-bang trajectory planner. So I would add a 0 each time. So now if we tried it on a jerk limit of 500, I'll stop that continuation processor and we'll run it again. You'll see it's going much faster through the curves and it's not slowing down as much at the edges. Now what you could do is run a small test pattern and measure the job time on this job timer over here. This timer counts up whenever a job is actually running. Now it won't do us much good on this job because this is a subroutine with an empty return at the end. So this job runs forever as long as we sit on this screen. But anyway, if you time each run, what you'll find is the higher the jerk goes, the faster your job goes, but the more shuddering goes on in your gantry. So tuning a machine under the Auggie is just finding that sweet spot that you happen to like. I would do it with a large CV, find a nice point on the jerk curve that you like for your particular machine, and then reduce the CV radius to something that's appropriate for a job. And CV radius is something you might want to change from job to job. And that's all it takes to tune a motor in Auggie. There is no complex settings because the jerk is being constantly monitored and the path is programmed to always fall within the jerk limits of the path. So that's about it for calibrations. Have fun and let us know how your motors work out.